Hello, this section is entitled Security, Define Security Context. So the security context has to do with security within the containers themselves, or within the pod, the containers within a pod. And I think we'll just do this through a series of examples, talking about the different kind of things we can control sort of at the container level. So the first is, what we're going to do is just going to run a container here first, and we're just going to do some exploration, explore what kind of security concerns we might have at the container level. So let me run a container called, there's a folder container called none. So let's look at it real quick, what's in none. So none is here, templates. Okay, so this is just a pod running a single container running Ubuntu, right? So pretty much nothing special going on, and we're going to poke around it and see what sort of security concerns we might have with it. So Helm Install dev none. Okay, kube control get all. Should be container running, right? So let's log into it and poke around. Kube control, kube cuddle, execute, dev, and our terminal bash. Okay, first thing I'm going to do is there's a command called ID, right? That basically tells you a bit about your credentials as you're logged in. You can see that I'm logged in as root, UID 0, right? And my group is 0, right? And a member of the group 0. So basically on this, in this container right now, my credentials essentially, as I'm logged in, I have full control of the container as root, right? Which generally is a bad idea to run processes as root. And another thing we can do too is if I just use PSAUX, that basically shows all the processes, and in question, and then A is all the processes, and then user, I think is the user view, and X is those without a terminal. But basically, you can see that my tail command here, that's essentially the command that ran, kind of running the container in, right? Or the command that the container is running. It is also running as root, right? So one of the things we look at is, generally that's probably a bad practice. There's no reason for my tail command to need to be running as the root user on this container. And that's sort of a bad practice, okay? Now, so what we want to do is we want to lock, one of the things we're going to do is by using a security context, we're going to maybe lock this down some more. Okay, so I think what I'm going to do is look at another example. So let's take this, let's get out of this one. So what I'm going to do is I'm going to explore how to run that tail command, for example, more securely. Okay, so let me undo that one, uninstall dev, and I'm going to look at basic. Okay, so let's look at another example here. None, where's basic? Basic's here. And I'm going to look at the template here. I'm going to give two examples. I'll start with the simpler example first. This is a pod. It's running Ubuntu, right? And I've added a couple extra settings here. In fact, I think they're all down here at the bottom, right? And one is, let's look at the container one. There's allowed privilege escalation and read-only file system. So the allowed privilege escalation, so the definition is, let's look back here, I think I've got it written down. So basically this controls whether a process can gain more privileges than its parent process, right? And then basically by setting it to false, you're basically saying that if you have a process, the starting process, you cannot somehow get more permissions than what you started with, okay? And that's one of the, by there are viruses or mechanisms by which a process can gain more privileges than it's supposed to, and this prevents it. Okay. Now, to be honest, I was looking for an example where I would try to exploit this, and I didn't find it easily enough, so I didn't explore it. But it looks like one of the settings you want to do is just definitely want to turn this on to prevent, unless you're deliberately trying to do something that requires escalating your privileges. There's no reason to allow that. The other one is root file system. Read-only root file system. This should be pretty clear. If you really don't need to write to your file system, your process, right, then you can just mount the root file system as read-only, in which case, another whole category of risk is gone. So in this example here, you can see that I enabled both. I do not allow any escalations, and I mount the file system as root, as read-only. And the good point here is that my tail command, does not require writing to the file system, as do a lot of modern API. Like if you were writing a Node API, you're often not writing to the file system. You're just running everything in memory. Okay. Now the other one is there's other two settings we've set. Notice I set these at the pod level. So these particular one, run as user and run as group, I could have defined them at the container level, or I can also define these two in particular at the pod level. Either will do essentially the same thing. I just wanted to show that you can do some at the pod level. Now it turns out that not all of them can be put at the pod level. For example, just trial and error, this read-only root file system, if you try to put it out at the pod level, it will fail, right? So I think the only ones that can go out to the pod level are the ones that have to do with users or groups. Those can be done either at the container level or the pod level. So again, these could be either place. Now what these are doing here is, you notice that my user previously was root. In this case, I'm going to run the user as another ID, in this case 1000, and as group 1000, right? Now this user doesn't necessarily even exist on that system, on that Ubuntu image, right? You don't need a name for that user. You still can run a user as a different number, which is essentially a different user. And by doing so, you don't have, essentially you're not running at a root privilege at that point. So you can't do certain things. So we're just going to run this one and see what we can't do. Some of the things that don't work all of a sudden. Okay, so let me go here. Okay, so Helm Install Dev Basic. Okay. And okay, so group control get all, control get all. I'm going to go and log into it. That's right. There's two of them here. I'm going to go to the first one. We'll look at the FS one here in a minute. User group dev. Okay. Okay. So the first thing it notices, it says it can't find a username or a group for 1000. But indeed, I am running as those credentials. My user ID is 1000, and my group ID is 1000, and my groups are 1000. And one of the implications of this is that, for example, I should not be able, like I'm the root of the directory, I should not be able to create a file here. Well, I also have a read-only file system. So even if I go to temp right now, right, normally I would create a file here. I could do that, but I can't do that now. So I can't create files. So pretty much I'm not a root user, and I only have a read-only file system. I'm pretty locked down. Okay, so I think that was really all I wanted to explain there. Okay, so this is, anyway, I'm pretty relatively safe on this OS. I can't do a whole bunch. Okay, so let's look at one more example here. And that's this example here, the second example that I'm running right now. This one's identical to the previous example, except for I've added one extra bit of complexity. I've created a folder called, an empty directory volume, right? Called it cache, and I mounted, so this is now a read-write volume, right? But one additional thing you can do is you can add a FS group, right? And so what happens is this allows you to control what group. So when I create a folder in the mounted file system, thus the FS, right? That when I mount it, when I create a file there, instead of creating it as the group ID 1000, which is the ID, the group, the primary user in this account, right? It's going to actually create the file with group 2000. And to be honest, I don't fully understand the value of that, except for maybe you have different pods, different containers in the same pod, and you want to maintain a common group. You run different, in different, maybe in different containers, you might run different users, but you want to have a shared group for any files that are in the common shared volume. That's probably the rationale for it. But let's just see what this looks like. So let me kubectl get all and kubectl execute user group fsdev it bash. Okay, so again, I'm not ID. I'm in user ID is 1000, group ID is 1000. I'm a member of groups 1000 and 2000. Right? And if I can't create files still. I'm pretty sure I can't touch test. Right? This is a read-only file system, but the cache is writable. Right? And so if I touch test here, ls all along, you'll notice that when I create a file in the volume that's mounted, right, right, you can see that the group is now 2000. So the second number is 2000. So the user ID is 1000, but now the group is 2000. If I had not set the FS, if I had not set the this FS group, when I create the file there, the group would have been back to 1000. And again, I think this allows you to have different groups and IDs for each your containers, but then have a shared group for all across all your pods that they can write into the same shared volume. Okay, that's that example. I think I'm done with this. Let me get out of this box. Install dev. Okay, so we'll look at one more example. Okay, so this is, let's see. I'm trying to think of, I don't think I had this example. Look at my code here for a second. Yeah, I did not cover this example, but okay. So one of the things that another security context you can do, I didn't actually activate it in my examples, but I'll just show you by. One of the things I could have done is I could have actually set. Let me go back to my original pod, my very basic pod. My none here. I could go into here, templates. Okay, in this pod, I'm running as root, right? I could also have done a security context here. So far of our security contexts have essentially restricted, lowered or increased our security. If I had come in here and done privileged true, which I'm not going to run it, but what this one does, this one allows this container now to have a more direct access to the node. So you don't only use this if you're writing containers that need to sort of operate on the node network directly and have more direct access to the node. So this is a super insecure thing to do. You would only do this if you absolutely needed to do some operation at the node level. To be honest, I've not written any of that code, so I don't know exactly what kind of things you would be doing, other than maybe getting access to the network directly and monkeying around at the node level. But again, that is another security context. In that case, by setting it to true, you're changing it from the default, which is false, in which case you're making the pod container more risky or more dangerous. Okay, so that I just want to mention that we'll use that later, because that's generally one of the first things you do, is you just probably want to prevent your containers from having that privilege. Okay, and if I can't remember, I think I set that at the container level, just so you know, not at the pod level. So that's a container setting. Okay, that's a common one that's mentioned in terms of security context that you probably want to lock down, prevent that from being true. Okay, so the next thing we'll look at is capabilities. This is another kind of in the same vein of how do you further secure your containers. Now this was completely new to me. I hadn't done Unix in a while, but in Unix, generally there's two concepts of processes, right? You have those are basically privileged processes, right? And by the way, this is different than the privilege we just talked about. In this case, this is like kind of more like our, when I was logged in as root, right? So privileged processes basically means is your user ID for that process is 0, okay, or root, right? So that would be called a privileged process. And then the other example was unprivileged processes, basically any user ID other than that. And earlier we had done that, right? We had started off with the none pod or the none example, and that one ran as root. That was a privileged process, and then we used the user ID 1000, and that was an example of an unprivileged process. Now, what's tricky is that sometimes you need to write, and I'm not going to write any examples of this, but you need to write an example where, I'll write an example, but I won't give you a concrete example. Well, we'll get to that. So again, you have these two extremes. One is you have your root, and you can kind of do anything on the box you want. And one is you're unprivileged, and you're really constrained in what you can do. And the point is there's a gray area between the two. And I guess Unix has a concept of capabilities, which allow you, when you're logged in as root, you don't necessarily have all the capabilities of root. You can actually dial back what it means to be root. Okay, and that's what this basically you can control. You can have sort of a watered down super user, and the way you do this is you enable capabilities or you disable capabilities, and that allows that user to have more or less access. Okay. Now, one thing that's interesting is, we'll look at this in a second, but when you get a container that's running as root, right? And we'll actually run it, and we'll look at it and see what it is. You actually get a certain level of capabilities as root, kind of built into the container. Okay. And what we're going to do is we're going to be able to monkey around with those capabilities, either add them or remove from those set of capabilities. So I think the easiest way of seeing this is, let's go back to our none example, which is where we're logged in as root, and let's see what capabilities that Ubuntu container kind of ships with for root. Okay, so this might make sense by example more. So Helm Install dev, back to a basic or none example, which is just an Ubuntu pod running as root. Okay, nothing special. Okay, so kubectl exec. I think this is example dev. Okay, so I'm root right now, and what I'm going to show you is there's different gray levels of what it means to be root, and that's what capabilities are given. What's the whole point of capabilities? So let me install a library, because there's a tool which lets you look at your capabilities, but you only get it if you have installed something. So let me install something that will help us explore what capabilities come pre-shipped on this Ubuntu image. Apt get install libcap 2-bin. So what this is a library set of tools for monkeying around with capabilities, essentially. So I didn't actually do anything in my system other than install some software. And the software command line is, here it is right here. This was new to me. So it's cap, show, so capabilities show, and then print. Okay, and your current set of capabilities are the one that says current. Now I don't fully understand the bounding and all the other settings, but the one that seems to be the most important, at least for our context, is what are my current capabilities? And you can see I've got capability chown. These are various basically command, like chown is a command line tool that allows you to change ownership of a file, right? So there's a number of these that you can do. Now there's actually a full list. Let's see if I can get to it. Yeah, if you go to here, on the manual page on capabilities, they talk about what all these capabilities are. So again, these are sort of root level capabilities, and one of which we're going to look at is chown, right? So chown is make arbitrary changes to file UIDs and GIDs, which is basically changing the ownership of a file, right? And what we're going to do is, through an exercise, we are going to change it so that the root user cannot use this command. Okay, so you can see right now that I do have that capability here, which means I can go to the temp folder, for example. Right, I'm in temp folder, touch test. Okay, and then let's see. If I look at test right now, test is owned by root, and the group is root, right? But I can go chown, change owner. I want to change it to there's a user called nobody, right? Test. If I now look at this file, it's now owned by nobody. So right now, this root user has the capability of chown, which means that worked. So let me illustrate another example. So let me clear this out. Helm uninstall. Okay. And if I go under cap templates pod. Okay, so this is just my regular Ubuntu, right? Except for I have added this capability, and I notice it says drop chown. So what this is going to do is going to that container, looking at the list of default capabilities for the root user, and I'm dropping out chown so that root user can no longer change ownership of files. Okay, so let's validate that this does what I just said it would do. So if I do helm install dev cap, okay, kubectl get all, kubectl execute example dev. Okay, so I'm root. I should go to temp folder, right? Make a file. Touch test. LSL long. It's owned by root. Chown. Nobody. Test. Change of ownership permitted, not permitted. So all of a sudden now you can see that I apparently don't have that capability. Now, one interesting thing too is this particular setting, by turning off chown, I can't even use apt-get to install things because apt-get expects that the root user can change ownership of files. So I actually tried to install the libcap thing, and I couldn't get it to install because I don't have the rights to chown, which apparently is assumed to be available when you're installing software. So now again, the big picture here of this whole exercise of looking at capabilities is more than likely, if you're running a normal application, right, you're really going to be running your user not as root in the first place. You're going to be running more likely just as a regular user using your setting your user in group, like we did in that example, right, where we used what was it we were using? We were look at the code. So more than likely, you're going to be using something more like this template here, where you're setting run as a certain user that's not privileged, and then you're fine. If, however, you have the need to do some super user-like activities, rather than just running it full-on super user with all the capabilities, you might want to explore using this capabilities feature and drop out the capabilities, all but the one you really need. Right? You want to be running with the least amount of privilege as possible. And that's what this whole capabilities business is. It's sort of a semi-super user. Okay. So that's capabilities. Okay, so that was kind of, so far we've been operating at the individual pod level, right? We've been, as a developer, right, we've been setting the security context mostly on the container, but in some cases at the pod level. And we're going to switch gears now and think about maybe now I'm a system administrator of the whole cluster, right? And I want to enforce that certain containers. The scenario is I don't want my developers creating these privileged containers. I want them to follow best practice and create pods and their containers that they have that are more secure than just wide open, right? Maybe I don't want them to run their containers as as super. They have to be running as a certain user, for example, or I want them to not be able to run privileged containers that have access to the node. Right? That's an obvious one, right? So the idea here is you can actually create what's called a pod security policy that controls what kind of pods are being created, essentially. And to be honest, this thing's fairly complicated. It was more complicated than I thought it would be. So let me see if I can give it. I have a good example of all this, and let's see if I can do a good job of explaining this to you. Let me get out of this. Helm uninstall dev. Okay. Right. Okay. Okay. So let's see if I get this right. So first of all, out of the box, Kubernetes doesn't necessarily support pod security policy. You actually have to turn it on before it is usable. So that's the first thing. The way it's turned on has to do with, it's basically it's an admission controller configuration. So what that means is that as you create pods, there's going to be a check to say, does this pod meet, pass muster or not? Is it too risky or not too risky? And you may have pods that just can't be created once you lock things down with a pod security policy. That's the main point, right? Now the tricky thing is, if you don't do anything first and you just turn on this admission controller enabling pod security policy, but you have not taken any precautions, you will essentially break your system because if you have not created the security policies first, but then you turn on the mission controller before you define anything, then no pod can be created. So like all your daemon sets will fail. Pretty much your system will not even be able to start, right? You won't have DNS. All sorts of stuff will break, right? So the documentation is pretty clear that before you turn on pod security the policies and mission controller, you have to preset up your policies so that they actually will allow your system to operate before you turn it on. Okay, that's another sort of observation. Now, the good news, we'll find out that if we're using EKS, they have enabled this mission policy, but they've already preset up some pod security policies to basically open up the system as if you didn't even have, like basically it just says, okay, it's a free-for-all. It says their default policy is turn everything on so you can do anything you want. Any pod will work, okay? And I think it's really instructive to see how they accomplish that, because that'll tell us how this pod security policy works, okay? I think the easiest example here is, before I try to read all this, is let's look to see how this is kind of under the hood, how EKS has implemented, how they allowed our system right now, without any configuration, or on our part at least, to allow any pod of any type to be created, right? I was able to create a privileged pod. I just did it a minute ago. It was kind of a free-for-all. So I think the easiest way of seeing this is by example. So if I say kubectl get PSP, there's pod security policies, okay? And there's one already created, and I didn't create it. This was created by Kubernetes. I mean, not by Kubernetes, by EKS. So let's describe it real quick and just get a sense of what these things look like. Pod security policy, EKS privileged. Of course I didn't get it right. I'm always misspell these things. That's EKS dot. Okay, so I'm not going to go through every setting in here, but if you look at this, you'll kind of realize what this looks like. The settings look like a bunch of allows. Do I allow privileged? True, means I'm allowed to run, basically this policy, if somehow I can, this policy applies to me, then I can create pods that are privileged. And I can create pods that have privilege escalations, which we saw. I can basically, I have no constraints around what capabilities are added or dropped, right? I'm allowing any capability, right? I'm allowing any volume types, blah, 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 right? And then the users, I think there's this, basically, where's the registry? Oh, right. I basically you're allowed to run as any user you want, including root, right? So you can see that this is an example of kind of a wide open policy, right? That allows for any pod to be created with any level of or lack of security, okay? So that's the first thing. That's what a pod security policy looks like. Actually, I can just get it real quick and see. You can see what it looks like. Get YAML. So it looks something like this. It's a pod security policy, right? Forget all these annotations for now. Labels. So the spec looks like something like this. Like allow escalations, blah, 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 blah. So again, this is basically a wide open example. Okay. Now the question is, well, how does that pod security policy apply to pods, right? I mean, here's the first thing is just creating one of these does nothing. Okay. It doesn't allow anything. It's just sort of floating there. And what's tricky about this is you got to tie these back, okay, to well, let's just look through it slowly. Okay, just creating it is not enough. I'm going to look at it. I described it. Okay, so cluster role. So this is a role-based access control issue, right? So what I'm looking at here is a cluster role, okay, and it is of that, and this is just a name of one that's already pre-created here.
So what this is, if you look carefully at this cluster role, if you're if you're bound, if you're connected, if you're bound to this role, right, or right, if some security object, like either a user or a system system ID. What am I thinking about? System account, right? If a user or a system account are associated with this this cluster role, right, then you are basically allowed to use, this is the name of there's just a lot of acronyms here, right? You're allowed to use this pod security policy, right? So basically the idea is having this cluster role or being bound to this cluster role allows you to use that policy, right? And that policy is pretty much wide open. So by being able to use that policy, it says, in this case, I can create pods of any shape or form I want, essentially. Okay. Now the question is, well, how does having a cluster role, how does that apply to, how does that work? How is that bound to anything else, right? Now the first thing is, because so let me get this right. Because I'm logged in as a cluster admin, right? I can basically, if you look at my security policy, my role, right, for a cluster role, I have access to everything in the system, including this policy. So what happens is, because I be able to do anything I want with anything, this policy becomes available to me. So if I try to create a pod as a cluster admin, it says, oh, I can see this policy. I can see this policy called EKS privileged, and because it's wide open, any pod I create is fine. Okay. Now, what's tricky about this is, and this is super subtle, even as an admin, I may create a deployment, right? Deployment then builds a replica set, and the replica set is what actually builds. If you think about how replica sets work, right? The things that actually create the pods in that case are the replica set, not me, the user cluster admin, right? Or the cluster admin user. And so what's tricky about that is, in that case, the user, quote unquote user, that needs access to this pod security policy is the pod system account. So every pod member, if you remember, every pod is associated with a system account where it runs. Usually it's the default in the same namespace, right? And that account is got to be associated, in order for that replica set to create that pod, it's going to be looking for pod security policies that are associated with that system account. And if it can't find anything, it can't create the pod, okay? So there's got to be, right now, I can create as admin, just knowing what I know now, just because of the security policy, as an admin, I can create pods all day long. But replica sets, unless it's something, we'll look at here why they work, but what we've seen so far, it's not clear that replica sets should be able to create pods, but somehow they know that they work because we've been using them, right? And the reason why they work is, again, I do apologize, this seems a little bit convoluted, but so what makes it work, there's a cluster role binding, right, that's also pre-created with EKS, okay? And let's look to see what it says. This cluster role binding says, okay, the point here is, so this is tying to the role, the cluster role we just saw, right? So this is the cluster role that we looked at that allows, if you have this role, right, then you can create pods of any shape or form you want, right? And you notice that any authenticated, this is system authenticated, it means any user or any system account is authenticated, then they can use that pod security policy, okay? So this right here is what allows any user right now, as it's configured, any user or any system account, right, which means any replica set, can create pods of any shape or form they want. So this is basically what's opening up our cluster to anybody who wants to create anything, right? Now the point is that we want, so that's kind of how it works. So the big picture is the way you control access to what kind of pod you can create is you create a pod security policy, right? And then you connect it back. In this case, the best practice is don't think about tying it back to users. You want to tie them back to system accounts, because that's really, usually you're creating replica sets which then create the pods for you. So you want to think about tying your pod security policies back to these system accounts, and you want to maybe give different system accounts, right, different pod security policies, right? And you certainly don't want, just so you know also, if one particular system account can see or have access or use multiple multiple pod security policies, then it opens up to the one that it'll try every one of them until that pod can be validated. So it goes to the least restrictive one. So in this case, if I had left, as long as I leave this particular binding in place, then nothing I do matters. I can't really lock this system down, because this just having this one policy available to every system account right now essentially unlocks every pod capability, right? For every namespace, every pod can be basically made wide open, and there's no way to reduce right now as it's configured. There's no way to reduce the access unless I do one thing, and that's what I'm going to do in the next section, right? So what we want to do is, what we're going to ultimately do, I'm going to do it in I'll do a different order than I originally said I would do here. So right now, so it's this cluster role binding right here that is opening everything up, right? So the next thing, the extreme thing I'm going to do, I'm going to do it in a certain order here. Let me do this. Cube, Control, Delete. So I'm going to delete this cluster role binding, right? And what this is going to do is, it won't break anything right now, but if I try to reboot my cluster, I think bad things would happen. So let me delete this first. So by deleting this cluster role binding, I'm in a state where there's a pod security policy still out there. There's even a cluster role that allows, if you have that cluster role, you can create pods of any shape or form you want, right? The problem right now is that cluster role is not associated to any account, right? Or system account or user account. So right now, if I was to reboot I'm not going to do it, but if I was to try to reboot my cluster right now, all those daemon sets that try to come up, all those replica sets have their system accounts that they use will not have the ability to create any privileged pods. So I'm sure a lot of those pods have privileges, like some of the cube ones, the cube system ones. I'm sure they got some, they do some stuff that are privileged, right? So the point is that right now I'm in a bad state because I basically not allow almost any pod to be created at all. Okay, actually, let me phrase it this way: if you don't have access to any pod security policy, you can't even create a pod. So actually, even if they were regular pods right now, since none of those accounts are bound to this pod security policy, and there's only one pod security policy, and no one has access to it other than maybe the cluster admin, right? Because he has access to everything. This system can't even create pods at all. Okay, so we're in a bad state. So I deleted this, but what I'm going to do is I'm going to restore. Well, I'm going to show you my example. It's confusing enough. If I go back to this PSP system, okay, and I go to templates, what I did was, the first thing I did was, the way I created this, I went to kubectl get namespaces. So I got a list of all the namespaces, right? And outside default, I mean, default is the one I've been using as my developer. And the rest of these, in my mind, are essentially system accounts, system namespaces, things that I don't monkey with, right? And a lot of these probably have, well, they run pods under them, right? I mean, there's pods running under system, there's pods running under dashboard, Prometheus has pods, and I don't really know exactly what capabilities those pods need. So my goal here is I'm going to go back in now, and for each of those namespaces, I'm going to allow those namespaces to use any pod they want. So pretty much restore back the freewheeling, create any pod you want strategy for those. But I'm going to leave default alone initially. I'm not going to touch default. So the way I did this, and there may be better ways of doing this, but I couldn't think of it. So for each namespace, I created an entry here. So here's, for example, I'm just going to look at one of these, but they're all basically the same. So I'm going to create a role binding, right? So this is namespace specific. This one's for the namespace of cube system, right? And what am I doing? I'm taking, so this is that cluster role that I had looked at earlier. This is the wide open cluster. This is the cluster role that grants you access to the wide open pod security policy. Okay, and I'm assigning it to, right here, to any system account, service account. Yeah, I think I was saying system account earlier. It's service account. I'm assigning this to any service account in the cube system namespace. So basically, this means that any replica set or anything that's trying to create pods, right, in the cube system namespace, right, this will allow the pod to be created, and it's tied back to this pod security pod that's privileged, which means it can do anything it wants. So this basically restores normality to the cube system namespace. And I did this same pattern for each of the namespaces except for default. You notice the default is not in this mix right now. Okay, so what I want to do is I want to apply this one, and then except for default, everything should work as it did before. Okay, and I've already messed with this already, and I know that it works because what I did was I did all this, rebooted my cluster, hoping I didn't blow everything up, and everything came back up just as expected, right? So what I'm going to do here is I'm going to go here, CD 33. I'm going to go Helm Install. Now this one I'm going to call PSP System. So what I'm going to do is I'm not going to name this one Dev because I want to keep this one around kind of permanently, because without this in place, my cluster won't start, right? I need to kind of leave this one around. So I'm going to call this one PSP System. So you can now just for giggles, we'll look to see what I just look at one thing I just deployed here. So if I go to Cube Control, okay, let me see if I hit Get role binding namespace cube system. Okay, the one I created was this one right here, 22 seconds ago. So I want to see what this one looks like. Let's see. Cube control describe role binding this in the namespace cube. Okay, so you can see what this is doing. This is right. So this takes that cluster role, the one that EKS created, right, which again ties it back to the open pod security policy, and I'm associating it with the group of accounts, basically any account, any system, any server's account in cube system namespace will have access to this essentially. Okay. Whew. Okay, so right now I'm fine, right, in terms of all my namespaces except for default. I didn't create one of these for default. Okay. So here we are here. So what I'm going to do is, to illustrate that I have a problem, I'm going to try to deploy a regular deployment. So let's look to see what I'm trying to deploy. So I'm going to try to deploy So I'm going to claim that right now I have sort of a broken state, because in my default namespace at least. If I look at this template, I'm not doing anything fancy here. I'm just going to run, this is a deployment, right? Try to create 3 replicas of basically an Ubuntu image with no special privileges, right? It's just a regular, now we'll run as root, but I didn't say anything special here. This clearly should work in any normal world, right? Or well, I mean, in this unsecured world, this should work, right? Now, what's going to happen right now, you'll see, so I do Helm Install Dev Deployment. Let's see what happens. It will deploy fine, but you will notice that I have no pods, right? I have a replica set that's trying to create 3 things, but it's currently got 0. So let's describe what's going on with this replica set and see if we can figure out why is this thing complaining. Okay, so you can see it actually tells you what's actually happening right here. Error creating pods, right? Forbidden, unable to validate against any pod security policy. Okay, so right now it says that this, so what's really happening under the hood here is there is a service account, get service account. There's a service account called default, right, in this namespace. That account is not bound, there's no role binding to that maps it back to a role that has access to any pod security policy. So this sort of account essentially can't see any pod security policies, and as such it can't create any pods at all, privileged or not. Okay? So we need to fix that. So Helm uninstall dev, okay. So I'm going to get rid of that real quick. And I'll look at the fix here and see what the fix is. Okay, so if I go to the fix, there's another one deployment here, or another chart here called PSP default. So this is the fix that I'm going to put in place. Now there's 3 pieces of this, right? So the first thing I need to do is create a new, in this case, I don't want to bind this one directly back to the same wide open policy, right? Maybe I want to lock down default so that you can't do certain kind of things. So I want to limit the number of kinds of pods that you create in the default namespace. So the way I do that is I first got to create a pod security policy, right? And what I did was I took the pod security policy example that was wide open, right? So it started with basically the one that shipped, right? And then I made only one change to it, just so you know. I basically said privileged false. So again, privilege is what gives you access to the node. And I thought, okay, that's an easy one to change, and it's easy to test. So right now, having this, if you can map yourself back to this pod security policy, you'll be able to create pods all day long to do all sorts of stuff, except for you will not be able to create any pods that are privileged, right? If you do, you'll be rejected, right? So what I want to do is somehow get it to the point where the default service account for the default namespace has access to this pod security policy. And that's what my goal is, right? So I've got my pod security policy, and the next thing you're going to do is you got to create a role, right, that grants access. So this is basically says, look, if you have this role, right, you get access to the pod security policy named unprivileged. That was the name of the pod security policy, dash release name, because I've been doing that, right? So if you're bound to this role, which means essentially now you can now use that pod security policy, okay? So that's the role, but now I've got to somehow tie this back to the service account default, right? or any service account. In this case, I want to do any service account in the default namespace. So that's going to be a role binding, right? So this one says, okay, I'm basically, I'm tying it back to the role that I just created, right? And then this says any service account in the default namespace has access to this role now, or is bound to this role. Okay, so with those three things, I'm going to claim that I'm going to be able to run. If I deploy this, I can now go back and I can deploy that last deployment I did. That's because that deployment will defaults to the default service account in that namespace, which then through this binding is bound to this role, and that role has the ability to use that pod security policy. So it's layered here, and that's why this is a little bit confusing. Okay, so let's deploy it and see that it really does what we expect. So, okay, Helm install PSP default. The reason, again, I'm naming it this because I want to keep it around, because I want to be able to create pods in the future in the default namespace, and I want to keep this. I'm going to keep this Helm chart installed indefinitely. Now, in reality, you probably would need to think harder about how much. I mean, I really loosened it. This is still pretty wide open, that pod security policy. In reality, there's probably much more constraints you want to put on your pod security policy than what I just did. But this was easy enough to understand. Okay, so now I have kube control pod get PSP. So I should now have two pod security policies, right? One of them is the one that was shipped by EKS, which is just wide open. And then this is the one I just created right now, right? And the way that I've constructed this is that every other namespace that exists currently can basically, all those system service accounts in there have access to this one. And then I've granted, though, for the default namespace, I've granted any service account in the default namespace only access to this one. Okay, so let's see if we can deploy our regular deployment. So kubectl, Helm install dev deployment. I'm going to claim that this deployment will go through, and hopefully it does. I should be seeing pods, and I see my pods now running. So they're running. The replica set was able to now create the pods. That's because they had access to that pod security policy, and I didn't violate any rules in that pod security policy. Okay, delete Helm uninstall dev. Okay, so now I'm going to do one last example that will break, right? What I'm going to do is I'm going to basically use the exact same deployment I did earlier, except for I'm going to say that these pods, or the containers, right, should be privileged, which means they have access to like the node, right, more directly, right? And that was one of the things that I specifically prohibited in my pod security policy. And the hope would be is that this should get stopped in the default namespace, that is. So Helm install dev deployment priv. Hang on, make sure my containers all stop. So kube control get all. Yep. Okay, so kube control. No, Helm install dev deployment priv. Okay, kube control get all. I should not see my pods, so that's interesting, right? No pods. And I'm basically, what is going on? Let's look at kubectl get replica set. Okay, apparently didn't kubectl. Okay, No, I don't want to describe it. Okay, so what does the error say? If you look down here, it says error creating pods is forbidden, unable to validate against any pod security policy, right? And it's saying basically tells you what's wrong. I've set the security context of privilege to true, and privilege, and basically this wasn't allowed by that pods. The only pod security policy had access to was the unprivileged one, which did not allow this specifically to be true. So I could not create it. Now my replica set will not create any of these kind of pods. Okay. Whew. Now, interesting enough, so that's the replica set can't create it, right? Now, interesting enough, as the cluster admin right now, if I wanted to run a pod that was privileged in the default namespace, I still can do it because my credentials, like I get, something for giggles. Let's go to, I'm gonna do it though, just for fun. If I go to none, this is off script here, which is dangerous and barely hanging on as it is. So this is security context I can never spell this. I believe this is how you do it, right? So you notice that I'm creating a pod now that says privilege true, and if I didn't misspell something somehow, this mess, Helm install dev none, dev 2 none. Oh, what did I just do? Where is it? So close. You can see my pod is now running, and indeed, scribe pod example dev 2. Really? Describe. So you can see container. Where does it say privileged? I guess I can't see it from here. Get pod. Right. So you can see my container is definitely privileged true, right? And yet I was able to create it, right? And the question is, well, how did that happen? I thought we locked down that namespace. Well, it's not. It's only locked down for, basically right now, because I'm cluster admin, I can see all the cluster. I can see all of the policies, right? Irregardless of any of the the bindings, right? Which means that I was able to see get pod security policy. So I was able to see this one right here. So I could see both basically, right? And again, the way it works is it's going to look through the list of the available pod security policies, in which case I have all of them, and any one of them that passes will let the pod through. So that's why as cluster admin, I was able to create the pod. But the system account, what the replica set is depending on that system account, service account, in that namespace to do it. It did not have access. It only has access to the one. That's why it couldn't create it. Okay. So to be honest, this is a very confusing topic, and hopefully I made some sense out of this for you. Hopefully, if not, maybe the examples will make more sense. Thank you.